Good afternoon. Today we want to talk about statistics, and statistics is nothing more or nothing less than arts and science of learning from data. Well, what probably we mean by data? Let's say we did a survey with bunch of peoples, and we want to find out what is the fruit they like the most, and let's say apple, oranges, bananas, kiwi fruit, blueberries and grapes. These are the given choice. And let's say 35 people said they liked apples, and whatever 30 people they say they liked orange, and let's say 5 people they say they like banana, and number of people like kiwi fruit, number of people like blueberries, and number of people likes grapes the best. This is what we call data. This is what data and statistics is about, learning something from this data. Well, in statistics, in order to learn something from data, the first thing we do, of course, is collecting the data. So, collecting the data means I have to go find a bunch of people and create a survey that has name of these fruits, and then I have to distribute them, or I have to interview them asking what kind of fruit do you like the most. So, I need to have some kind of method, some kind of model to gather, to collect this information. That is what collecting data means. And once the data is collected, in order to learn from the data, in order to understand something from the data, one of the first thing, one of the primary thing we do is draw some kind of graph. We want to represent the data using graph. So, we want to create graphical representation of data. So, there are various kind of graphical representation of data. One of them is called bar graph. Well, bar graph means on the horizontal axis we put the different categories we have. So, in this example I was thinking of different types of fruits. So, I am thinking of different categories of fruits. So, in the horizontal line we put the different types, and in the vertical line we put the number. So, for example, 35 people like apples, 30 people like oranges, 5 of them liked banana, looks like 25 kiwi fruit, 40 of them liked blueberry, and 5 of them liked grapes. So, this will be the bar graph of this data. So, bar graph is a graphical representation of a data where horizontal axis contains various types or various categories, and vertical axis represents how many of in each category. That graph is called bar graph. Another graph that we use to represent data is called pie graphs. In pie graph, we draw a circle. We draw a circle and divide the circle proportionately representing number of people in each type. That means we will have a circle, and that circle should represent the circle should be divided in such a way that the parts of the circle should represent various types of observation in our data. Right now here is a pie graph, and this pie graph is about what kind of movie do you like, and there were 4 people who said they liked science fiction. There was one person who says they like drama, 6 of them they said they like romance, 5 of them they say they like action movies, and 4 of them they say they like comedy. So we divided this circle so that this represent 4 of them, and similarly this represent 4 of them. So basically this is the 20% of the data, this is 20% of the circle, this is 5% of the circle, this is 6% of the circle, and this is 5% of the circle. So to divide the circle according to the percentages occupied by a particular category is what we call pie graph. Now we are trying to divide a circle. In order to divide a circle, we need to know how much angle we should assign for each category, how much angle should be assigned for each category, and the formula we can use to decide angle. In order to calculate the angle, we can use this formula, the percentage divided by 100 times 360. So we can use this formula. That means since the science fiction people, there are 20% of the people who like science fiction. So for science fiction, this angle will be equal to percentage is 20 divided by 100 times 360. So this is 5, 360 simplified 5, oh my God, 6, 72. So this angle for the science fiction has to be 72, and similarly because comedy represent 20%, this angle has to be 72. Action represent 25%, we have to be doing the same calculation for action. If we want to find angle for action, it will be 25 divided by 100 times 360. So well, that's 1/4 of 360, so this angle has to be 90 degree, and so on. That's how we calculate the angle. First calculate the percentage in each category, divide the percent by 100 and multiply by 360, we get the angle. So that's a pie graph. Another graph that we use in statistics to describe data is called pictographs. The name itself is telling what it is. By pictograph, we mean using pictures to represent the data. In the bar graph, we use bars to represent the data. In pie graph, we use pie of a circle to represent the data. Now in pictograph, we use pictures to represent the data. Here is an example of pictograph. This is a pictograph for favorite pizza topping. What kind of pizza topping do you like the most? And one pizza slice is representing here 5 pizza according to this picto chart. So there 5, 10, 15, 20, 25. So there are 25 people representing cheese pizza. Similarly, 20 people represents 1, 2, 3, 4. Each of the piece of pizza is representing 5 pizzas according to this description, according to a key given to us. So there are 20 people liking mushroom topping, and 1, 2, 3, 4, 5, 25 liking sauces, and 1, 2, 3, 4, 5, 6, 30 of them likes pepperoni pizza. That's pictograph. Pictograph is almost the bar graph, except we use picture to represent the data. Then we have line plots. In line plots, we draw a line and put either a dot or a cross or something like this. You know, some people put a dot, some people are putting cross to represent the data. For example, here is a line plot, and this line plot is about weight of dogs, and it's one cross here represent one dog. So, since we see there are two crosses above 10, 11, 12, so that tells me there are two dogs whose weight is 12, this should be in kg, so 12 kilogram, and there are 1, 2, 3, 4, there are 4 dogs whose weight is 15 kilogram. There is one single dog whose weight is 16 kilogram. There is one dog whose weight is 18 kilogram. There are two dogs whose weight is 20 kilogram. There is single dog whose weight is 22 kilogram, and so on. So, this line graph is representing the data that consists of how many dogs, that consists of weight of various dogs. Another graph that we use in statistics is called stem and leaf plot. In stem and leaf plot, let us say we have numbers like let us say 5, one of the observation is 5, then 25 and 35 and 37, 38, something like this. In stem and leaf plot, what we do is the last digit of the numbers in the data, we use them as a leaf, and anything before the last digit is the stem. Anything before the last digit is stem, the last digit is leaf. So, a stem and leaf plot will look like this. Now, looking at stem and leaf plot, what we should understand is there is an observation whose value is 0, 1, 0, 1 means simply 1. There is another one, 0, 1 means simply 1, there is 2, there is 3, there is 4, 1, 2, 3, 4 fours, 1, 4, 2, 4, 3, 4, 4 fours, there is a 5, there is a 5, there is a 8, 10, 10, 10, 3 10s, 2 11s, 1 13, 1 17, 1 19. Similarly, there is 25, again 25, 2 of the observation are 25, 27, 27, 28, 28, 29, 29, and similarly 52, 56, 57, 57, 58, 63 and 66, so on. So, this is another way of representing the huge data consisting of bunch of number. The method is very simple. The last digit is the leaf, anything before it is the stem. Okay. Another very famous graph that comes in statistics is called histogram, where the data, the numbers in the data, we will classify them into various classes. For example, and we note how many in each class. For example, this histogram, here we have a class that goes from 60 to 65, this is one class, and there is another class that is 65 to 70, and then 70 to 75, 75 to 80, 80 to 85, 80 to 85, and 85 to 90. So, we will count how many observation, how many numbers in our data are in between 60 to 65. So, this example is saying there are 3 observation in between 60 to 65. The number of observation in a particular class, sometimes called frequency. So, the frequency of the class 60 to 65 is 3. That means there are 3 observation, there are 3 numbers in between 60 and 65. Similarly, I am looking at that bar histogram, there are 3 observation in between 65 to 70, there are 8 observation in between 70 to 75, there are 10 observation between 75 to 80, there are 5 observations in between 80 to 85 and only 2 observations in between 85 to 90. This is the distribution, this is the table, frequency table, and the frequency table, this frequency table is represented by this graph, where the x axis is the classes and the y axis is frequency or the count, how many in which class. So, this graph is called histogram. So, histogram basically represents data, where data are grouped into various classes. The horizontal axis represent the classes and the vertical axis represents the frequency or the count or the number of observation in each class. Another graph is sometimes called line graph, and line graph, or some people call it time series graph also. What we have in this graph is the horizontal axis represents various time points. It could be days, it could be hours, it could be years. So, the horizontal axis represents various time points and vertical axis represents the observations we are doing. So, let us say we find the average temperature of January, average temperature of February, average temperature of March, and average temperature of April, and so on. Put the month on the horizontal axis, put the temperature on the vertical axis, that will be example of line graph. Right now, here is an example of line graph. It is representing people in a store. So, what this graph is telling me is at 10 a.m. there were 2 people in the store, at 11 a.m. there were 5 people in the store, at 12 p.m. see, horizontal is time, okay. At 12 p.m. there are 10 people in the store, at 1 p.m. there were 22 people in the store, at 2 p.m. there were 15 people in the store, at 3 p.m. there were 5 people in the store, and so on. At 6 p.m. there were 3 people in the store. So, basically horizontal axis is time point, vertical axis they are counting how many people are in there. Vertical axis should be the observation of our interest. In this particular example, they are interested in how many people are coming in the store. In some other cases, we might be interested in something else. So, basically horizontal axis should be time, vertical axis could be whatever we are interested in, temperature, maybe the price of stock of a company today, yesterday, today, tomorrow, and so on, and that could be a line graph too. Okay. Another graph that comes in statistics is called scatter plot. In a scatter plot, we will have a data, in fact, that consists of 2 observations. For example, height of people and weight of people. So, we have been observing two quantities associated with the subject matter of our study. So, we are noting the height and weight of humans. So, let us say 5 feet tall and the weight is, let us say 60 kg, and let us say this is 6 feet tall, weight is 160 pound, let us convert into pound, 145 pound, and so on. Now, in order to represent this data, we use a graph called a scatter plot. Scatter plot is simple. One of the 2 observation we are making here should be in the horizontal axis. So, we may say horizontal axis is height, and the another observation should be the weight. We might have kept weight in the horizontal and height in the vertical. 160 will be, let us say here is a 0.5, and let us say this y axis is divided so that this is 160. So, this dot represents this person. 6 145, so another person is represented by this dot, and so on, so on. This graph is called scatter plot. We are plotting points in the plane where x-axis is one of the variable and y-axis is the second variable associated with our study. Here is a scatter plot in this example, and this scatter plot is a scatter plot of math scores. The horizontal axis represent the score of student in the math final exam, and the vertical axis represents their SAT score. So we have two things in this scatter plot. One of the quantity of our interest is the math final exam, score in the math final exam, and another quantity of our interest is the SAT score. So for example, looking at this dot represents a student whose math final exam was around 33 and SAT score was around 1100. This observation tells me there is a student whose math final score is like 45 and SAT score is 500. So these dots represent both math final exam score and the SAT score. This plot is called scatter plot. Scatter plot are very useful plot that tells us the relationship between the two quantities of our interest. This scatter plot tells us the relationship between the math final exam and the STAT final exam. The relationship between two variables captured by a scatter plot is sometimes called correlation. So if we want to know either two quantities are correlated or not, then we can use a scatter plot and look at it, and we can, looking at the scatter plot, we can say, well, there might be a correlation, and we can say there might not be a correlation. So what is correlation? Let's look at this example. If we have a scatter plot like this, there is a dot, here is a dot, here is a dot, the scatter plot looks like this. The scatter plot looks like almost straight up going straight line. That indicates very strong positive correlation between the two variables of the interest, between the two quantities of our interest. We can have this scatter plot where we have dots kind of slowly going up, not in a straight line, but looks like the pattern is little bit going up. This means there is a correlation, weak correlation. Since it is going up, we should be saying there is a weak positive correlation. Going up means positive, very close to the upgoing line. Everything is very close to upgoing line means strong positive, while scatter around the upgoing line means weak positive. This is the example of a strong negative. See, the line is going down and all the dots in the scatter plot are very close to the straight line. Weak negative, moderate negative, and if we look at this scatter plot, you see the pattern. There are dots everywhere. You don't see upgoing or downgoing trend. That means there is no correlation. And if we look at our previous scatter plot, according to this scatter plot, there is no correlation between math final exam and SAT exam. So my math final exam does not tell me how will I be performing in the SAT final exam. Well, correlation in fact is a number. We can calculate a number from the data, and that number, the correlation, the number that represent correlation in statistics is represented by R. R represents the correlation in statistics. this R, the correlation between two observation is always in between -1 to +1. The correlation is a number in between -1 and +1. It could be -0.5, it could be -0.2, it could be +0.5, +0.2, it could be 0. However, it cannot be more than 1, it cannot be 2, it cannot be 1.5, it cannot be less than -1. That means it cannot be -1.2 or -1.5 or -100. Now, if the correlation is a positive number, that indicates the positive correlation, that indicates if we have to calculate the correlation for this scatter plot or this scatter plot, we will be getting a positive number. And because this is stronger positive, the correlation for this scatter plot will be bigger than this. Similarly, if we have to calculate correlation for this scatter plot, it will be negative. And it says strong negative, that means we will be getting a number very, very close to -1, -0.95. If we see a correlation between two numbers is -0.95, that means there is a very strong correlation. The scatter plot should look like this. Similarly, this is weak negative maybe -0.5, -0.6, -0.4, all those are weak correlation, and if there is a weak correlation, the scatter plot should look like this. And no correlation, if this is the scatter plot, either the correlation R is 0 or very close to 0, 0.005. If the correlation is 0.005 or -0.005, we should be saying there is almost no correlation. So, this is an idea of correlation and scatter plot. Now, once we have a scatter plot, and let us say we identify some kind of correlation, then we want to draw, we want to find out the curve that best fits the data. In case of this scatter plot, this straight line best fits the data. Best fitting means most of the data points are following that straight line pattern. And if we can find out equation of this straight line or equation of this best fit curve, we can make prediction. We can say, well, if x is 2001, y is, this is mean sea level. So, in 2001, the sea level of a particular place was like 35. So, finding the best fit curve have advantage, because once we have the best fit curve, we can make prediction, we can make inference about something unknown things. Well, the best fitting things might not be a straight line in this case. It is not necessary that straight line will be the best fit for a data, for a scatter plot. Sometimes the best fit curves might look like this. Look at the scatter plot. Scatter plot does some kind of wave. So, the best fit curve to describe the data will be something like this. It is not a straight line. Well, one of the thing we should be careful when we use graph is to know what graph to be used in a particular situation. This different kind of graph describe different situation, or they are useful in different purpose. In order to know that, we need to have a lot of experience, of course. And here is a link of a website. If you go to this website, they will be giving some guideline on which graph should go in which case. Let us look at a few examples. Let us say the following 40 scores are from a college mathematics test for elementary teachers. So, there are scores in a math test. One person got 92, another person got 78, another 75, another person got 78, and so on, 72, 76 and 69. These are the scores of 40 elementary teachers in a mathematics test. Now, what we want to do is we want to form a stem and leaf plot for this test score. And the next question we want to answer based on that stem and leaf plot is how many scores are below 70. And third thing we want to do is what percent of these scores are greater than or equal to 80. So, how many are greater than or equal to 80. So, these are the three questions we want to answer based on this data. Since we are trying to construct stem and leaf plot, the stem and leaf plot will look like this. Stem here, stem here, come on, stem here and leaf here. Okay. All right. In order to do the stem and leaf plot, the first thing we need to do is identify what is the smallest data, what is the smallest value in the data. So, if you look at this data, I see a 58 here, and I do not see anybody is scoring in the range of 40. So, the smallest looks to be 58. So, let us say the smallest is 58, this is the smallest. Now, next thing we want to identify is the largest. We want to identify the largest. I see a 92 here, I see a 95 here, and looks like 95 is the largest. So, the largest is 95. So, the smallest for this is a 58, the largest is 95. Well, so that means we need to, this observation, since the smallest is 58 and the largest is 95, means all the observations are in between 58 and 95. So, 58 and 95 means something could be 65, something could be 68, something could be 87, something could be 75. So, the leaf will be the last digit. So, the last one, 5 and 8, we will reserve that for leaf, and we will put the possible stem in the first column. The stem for, well, since the smallest observation is 5, I will start the stem with 5, then it has to be 6, then it has to be 7, then it has to be 8 and 9. These are my stems. Now, leaf. Well, now we can start filling out this table. The first observation, in fact, it is better to order it. So, in the line of 9, well, in the let us look at the group of 50. 50, in the group of 50, here is a 58. Group of 50 means 50 to 60. Here is a 57. Oh, 57 was the smallest. Anyway, it does not matter. That, and here is again a 57. And so that's it. So, in the group of 50 to 60, there is 57, another 57. So, this 57 is taken care of, this 57 is also taken care of, and there is a 58. It is always good to write in ascending order. Now, in the line of 60, I see a 67 here, I see a 62 here, and then I see a 65 here, and then 67 here, 62 here, 65 here, that is it. So, 62, one of them is 62, there is another 62, and 65, 65, 67, 67, 67. So, this 67 is considered 62, 67, 2 of them are there, 62, 2 of them are there, 67, 2 of them are there, 165. That's everything in 60s. Now in 70s, here is a 72, 75, 73, 74, 74, 76, 71. I don't see any 70. So 71, this is done. 72, this is done. There could be more 72s. Here is 172 and here is another 72. So 72, 72 and 73. Here is a 73. So 73. Do I have any other 73? No. So now 74, 74 1, 74 2, 74 1, 74 2. Do I have any more 74? 74, no anymore. Now 75, here is a 75, 75 and 75, here is a 75, 75, 75. I forgot a 68 here. So 275, 75, 75, here is also a 75. So I should have ordered them before, so I did not get so much confused when doing this. Now let's go in 80. Here is 81, 181, 85. Oh, here is a 80. So I will start from 80 and then 81. This is taken care of. 81. Do I have any 80? Oh, here is a 80. So I need one more 0. So let me check 80s. Here is a 80. Here is a 80. No more 80. No more 80s. Here is a 81. 81, 81, 81, 81. I don't see any 81, 81, 81, 81. I don't see any 81, 81, 81. I don't see any. So that's the only 81. So only one 81, two 80s. 82, 82. I don't see any. So 83, 83 is here. And where else? Nowhere else. 83. That's all I can see. If we find something later on, we'll put it in. There is 83. Next is 84, 84, 84, 84, 84, 84. Seeing none. Rather, I saw 69 here. So 169 at least. Then 84, 85. I forgot 78. So that 78 after 6, 5, the line of 7 there has to be 8. So after, oh, I forgot a 76 also, see. So it's always better to order it. Anyway, since I didn't order, you guys got the idea. So this needs to be filled in. And in the 90s, there is a 90, there is a 92. So 0, here is a 2. And where else? 95. I don't know how many. So we fill this in. This is called stem in leaf plot. How many scores are below 70? So below 70 means you will count anything below 70. That means you will count how many in the line of 5 and 6. So if I have counted everything in the line of 5 and 6, then the right answer will be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I can say 10. But I might have forgotten something. If I have, check it. What percent of the scores are greater than or equal to 80? Greater than or equal to 80 means we have to count how many here and how many here. How many here and how many here. Let's just for sake of argument, let us say the total number of observation in the line of 8 and 9 is 15 or 20 let us say, then it is saying percentage. In order to calculate the percentage, we divide this 20, there are total 40 observation, 20 by 40. So, that is 1/2 means 50%. This is how we construct a stem in leaf plot and use it to solve various questions associated with it. Okay, the following table shows the percentages to the nearest whole numbers of elementary schools for various size categories. So, there are elementary school of various sizes, and here is a table representing how many schools belongs to which size. The question is draw a pie chart. We want to draw a pie chart for this, and what percent of the elementary school has 500 or more student. We want to figure it out what percent of the percentage of the elementary schools has what percentage of the elementary school has 500 or more students. Well, this is already given in percentage, so that is fine. Percentages, yes. So, the next question we want to do is draw a bar graph. First of all, we want to draw the bar graph, and we want to identify again what percentages of the elementary school has from 200 to less than 500 students. So, from 200 to less than 500 here 500 to more student. So, let us look at this table. This table is this little small, but let me read the number. Under 100 there are 6, 100 to 99 9%, 200 to 299 13% of the school have 200 to 299 students. 16% of the school have 300 to 399 students, and similarly 16% have 400 to 499, 13% have 500 to 599, and so on. Now, we want to represent this data by a pie graph. In order to do a pie graph, the first thing we have to do is find out approximate percentages of this percentages. So, 6 is what percent of the total, that is what we will be interested in. 9 is what percent of the total, that is what we are interested in. So, this is 6%, so the total has to be 100 here. Okay. So, this is 6%. So, in order to draw the pie graph, we have to calculate the angle. Remember, angle is calculated by the 6 is the percent, divide that by 100 and multiply by 360. So, this will be 6 times 3.6, that is 21.6, and if we approximate this, it will be 22. So, the angle for the schools under 100 student should be 22 degrees. Similarly, using the same method, if we want to calculate angle for 9, that will be 9 divided by 100, it is 9%, and times 360, and that turns out to be 32.4, changing it, I am approximating it to 32. So, the angle for 9 has to be 32, and it continues similarly. We calculate angle for each of the percentages, and we get, and we draw a circle. We assign 6 degree to this category, under 100 category, 22 degree here, this is 22 degree, and we assign 32 degree. After that 22 degree, we assign 32 degree to another group and keep continue. Drawing by hand, I make a mess, so I will show you a graph, pie graph generated for that particular data using computer. So, Yeah, this is 16% are this, 16%, and that particular color yellow, that represent schools which size is from 300 to 399, and 1000 and more is very dark green, and I think that's 9%, or that should be 16%. Is that right? 5%, sorry, 5%. Wherever is that 5%? Here we go. This is the dark green. My color choice, that not good. Okay, now in order to construct the bar graph, remember the bar graph, we put the categories here. So one of the categories, this is 0 to 100, and another category will be 100 to 199. This is another category, another size is 200 to 299, and we draw vertical bars representing what percent of the school are in that category. This is called bar graph, or nicely drawn bar graph is here. So this is a nicely drawn bar graph. Under 100 there are 6%, 100 to 199 there are 8% or 9%, 200 to 299 there are 14%, 300 to 399 there are 16%, and so on. The bar graph will look like this. And we had another question attached to the pie graph and bar graph, and the question attached to the pie graph says what percent of the schools has 500 or more student. So 500 or more means we will be calculating percentage starting 500 all the way to 1000 and more. This will give us total of this, all the groups will give us the answer for this question. So looking at this table, we can say 6, 9 plus 6 plus 7 plus 0 plus 5, that will be 9. So that will be 9 plus 6 plus 7 plus 0 plus 5, which is 27. So 27% of the school has 500 or more student. And another question is what percent of the elementary school has from 200 or less than 500 student. In order to answer that question, we can 200 to less than 500. So it should be more than 200, less than 500. Let's look at the bar graph. So 200 to 299, 200 to 299 looks like 13%, and then 16 and 16. So 13, 16 and 16. 13, 16 and 16 gives us the total of starting from 200, 13 plus 16 plus 16, that gives us the total percentage of those schools. So 32 plus 13, 45% of the schools has number of student in between 200 to 500. If you have any question on various graphs, email me, call me. Thank you for watching. Have a good day.